Hello from ChemHelp ASAP. We're going to do a quick orbital bonding picture for the molecule hydrogen cyanide, also known as HCN. So on the screen we have hydrogen cyanide, HCN, drawn as a Lewis structure. The carbon is sp hybridized, its bond angle will be 180, and we assign it a linear geometry. So remember, when we talk about sp hybridization, we're going to use that carbon's attached to two atoms, so we need two of our atomic orbitals. And I'm going to specifically go with py. And I'm going to say py because in the right-hand corner we have this, I'm going to have the molecule written parallel to the y-axis. So I want to use the py. Those two atomic orbitals together are going to make two sp hybrids. Plus we're going to have unhybridized the px and the pz. So here's our carbon. It has a sigma bond to the nitrogen, and it has a sigma bond to the carbon. To make those sigma bonds, we used our hybrid orbitals, or sp hybrids. That means this carbon has on it unhybridized a pz. It also has an unhybridized px, and when we draw this px, we want to make sure that we draw it parallel to our x-axis. So to indicate that it's coming out of the plane of the page, we're going to draw it a little bit darker on one side, and I'm going to make it dotted on the other, and that's our px. And you can imagine these pictures, they can get kind of ugly because we got this stuff, these things poking out everywhere. But we're very careful to make sure it's accurate. Now what's going on with our nitrogen? Again, nitrogen's a terminal atom, so properly speaking, you might say we don't need to think about hybridization, but we have to know exactly where our electrons and bonds are going. So for this lone pair, let's say that needs a hybrid orbital. If that needs a hybrid, nitrogen also needs a hybrid to bond to carbon. That's two hybrids. It's also going to be sp hybridized. And we'll put that lone pair in the lobe of an sp hybrid. And it's also going to need, to make this triple bond, two pi bonds, it's going to need a pz to interact with a pz on carbon. And it's going to need a px to interact with the px that's on carbon. And we'll try to make sure we draw these kind of parallel. Now, how do these pi bonds form? Well, that's one pi bond. Both those interactions together are one pi bond. And then the px's also overlap. And we're going to show two interactions for those. That's also going to be one pi bond, two interactions. So it looks like we have 5 lines connecting our carbon and nitrogen. We have 3 bonds. Here's the sigma bond. This is one of our pi bonds, and the px's form another pi bond. So when you draw these orbital pictures and you start to get a lot of p orbitals, you must be very careful about keeping track of where your p orbitals are and where they are not, which ones went into the hybrid system. But if you draw them carefully, then out pops this picture where you can see your sigma bonds and pi bonds fairly clearly.